that we're going to look at is how to test whether a function is continuous at a given point or not. And then the second thing that we're going to look at to be the first principle. Yeah, so I'm sure from the video that I sent in the group, most of you know at least something about the first principle, except the versus continuity test. Okay, so let us see how we can check whether a function is continuous or not at any given point. So if we say a function, if we take, for instance, that point is A, and then we say, and then let's say you have a question, you have a question, or you find a question somewhere which says, determine whether a function f of x is continuous at a given point A. So the first thing that you need to find, or the first thing that you need to check first, is whether f of A exists or not. And how do you find f of A? Remember, when I taught you functions, if you, let's say you have f of x is equal to, let me just continue with this one. If, for instance, you have f of x is equal to 2x squared plus, let's say, x plus 1, then they ask you to find f of A. So if they ask you to find f of A, this means that you're going to be replacing A while there is x there. So you have 2a squared plus A, then plus 1. Yeah, so in this case, this A we're using is just standing here for any number, any constant. They can give you 2, 3, 4, any number. This can be any number. So in short, if you have f of x maybe which is equal to, let's say, x squared plus 1 over x minus 2, and then they ask you to say, determine whether this function is continuous at x is equal to 2. So what this means is that you first have to find f of A. And then what they mean by asking whether f of A exists or not is you have to replace these two in a function, and then you check if that function is going to be undefined or not. So if, for instance, we replace 2 in this function, in this one here, if we replace 2 in this function, we say, let us find f of 2 using this function. We're going to have 2, and then you have 2 there squared, then you have 2, then plus 1. So this is going to give you 2 times 4, then plus 2, plus 1. So this will be 8, and then you have a 3 this side. So when you add 8 and 3, you're going to get 11. So this implies that f of 2 exists. But if you replace this same 2 in this expression, if this is the function that has been given, you put 2 while there's x there, you discover that you're going to have something like this. F of 2 is equal to, on top you have 2 squared plus 1, and then down there you're going to have 2 minus 2. And this will give you 4 plus 1 over 0. And then when you simplify this, this will give you 5 over 0. So now, if you check, any number divided by 0 is undefined. So this implies that f of 2 does not exist in this case. So if this is the function that we were given, we can just end here on the first step and conclude that since f of A does not exist, meaning the function is not continuous at A. But if you find an answer like this one, like the 11 that we found here, this implies that you have you now have to go to the second step. If you discover that f of A exists, you have to move on to the second step. And in the second step, you have to find the limit of f of x. You have to determine whether the limit of f of x exists or not. So even for the second one, if you discover that the limit of f of x when x is approaching the same A does not exist, it means that the function is not continuous. But if you find that it exists, then you have to proceed to the third step. So now let us look at how you can determine whether the limit of f of x as x is approaching A exists. How can you know that? So this one is straightforward. What you just need to do is to check whether the left side of the limit exists. And also, rather, what you just need to check here on the second step is just to first check whether the left side of the limit of f of x, when x is approaching a from the left side, which is from the negative side, is equal to the limit of f of x as x is approaching the positive side, which is the right side. So these two should give you the same answer. So after replacing a in f of x, if let's say, for instance, the function that we've been given is a piecewise function, let's say you have f of x is equal to, then you have, let's say, x plus 1, then x minus 3. And then this first function applies to all values of x that are, all values of x that are less than, all values of x that are less than 2. And then, for instance, and then on the second one, I mean, this second part only applies when, applies to values of x that are greater or equal to 2. So the first thing that you need to do, if you have been given such a function, and then they ask you to determine whether the limit of f of x exists, you have to first find the left side. So when you say the left side of 2, we are talking about this part, which talks about numbers that are less than 2. And then when we talk about the right side of 2, we are talking about the x values that are greater than or equal to 2. That's what we mean. So if you've been asked to ask us to determine whether the limit of this function exists, you first have to replace this same value of a. So in this case, the value of a is 2. Yeah, so the value of a in this case is 2. So, or sometimes it may not be the number that is this side. They can just give you to say, determine whether this function is continuous at x is equal to 3. So meaning the value of x that you are going to take will be 3. But if you've not been given, you take this number that is this side, the common number between the two functions. So in this case, the value of a is 2. So we'll say if x is equal to 2, or if you're testing whether the function f of x is continuous at 2, what you just need to do is to replace first the value of x, which is this 2. You replace it in the first function. You also replace it in the second function. You see if you're going to get the same answer, this side and that side. Anyway, we're going to look at an example, and then we'll see how you apply these rules. And then if you discover that the limit of f of x as x is approaching a exists, you have to move on to the third step, where now you have to check whether the limit of f of x as x is approaching a is equal to f of a. What this means is that you just have to look at the first step there and the second step. You check if you're finding the same answers on the first and the second step, it means that the function f of x is continuous at that given point a. That's what it means. Okay, let's quickly move on to the to solving the example. So this example is saying, is the function f of x is equal to that? So is the function f of x is equal to this continuous at x is equal to 2? So how do you do this? Remember, the first step when you are testing for continuity, you first have to check whether f of a exists. So let's check if f of a exists. So at this point, we don't know whether it exists or not. So how do we check? So this one is straightforward. You check you check the first function, you also check the second function. So they're asking us whether whether the function is continuous at x is equal to 2. So how do you check that? You look at this function here that we've been given. Do we have 2 in the first function? The answer is no. Do we have 2 in the second function? The answer is yes. Why do I say we have 2 in this second function? Because when you look at the symbol that is between x and 2 here, we're saying x is greater or equal to 2. And because of this equal sign symbol here, it means that 2 is also part of this function. But on the first function, we're saying x is less than 2. So we only have numbers that are less than 2, and 2 is not part of the set. So we are getting the second equation in order for us to find f of a, which is f of 2 in this case. So to find f of 2 using this function, we're going to get the second function here because that's where 2 is. So we're going to say 3 times 2, and this will give us 6. So after doing this, we have found the answer, meaning f of 2 exists. So meaning f of 2 exists. Yeah, so f of 2 exists. So let's move on to the second step. So in the second step, we have to test whether the limit of f of x as x approaches 2 also exists. How do we check this? So checking this is also straightforward. What we just need to do is to check, so what we just need to do to find this limit is to check whether, remember what I said, you have to check whether the limit of f of x when x is approaching 2 from the left is equal to the limit of f of x as x is approaching 2 from the right. So what this means is that you first have to find this, then you also find this one. You check if they are equal, then the limit of f of x as x is approaching 2 exists. So how do we find this? Let us start with the left. Let us first start with the left. So the limit of f of x as x is approaching 2 from the left, this will be equal to. So when we talk about the left side of 2, we're talking about numbers that are less than 2. So we are using these functions. So when you talk about the left side of 2, we're talking about numbers that are less than 2. So we're using the first function to find the solution. So we're going to replace 2 where there's x, then we say 2 squared, then minus 2. So the final answer here, this will be 2 times 4, 8 minus 2. This will give us 6. So let us now find the limit of f of x as x is approaching the right side of 2. So the right side of 2, we're simply talking about numbers that are greater than 2, meaning we're using this function. So we're using 3x. So while there's x, I'm going to replace 2, and this will give me 6. So now, if you check the left side and the right side are the same, we're getting 6 on both sides. So this now tells us to say, the limit of, it tells us to say the limit of f of x as x is approaching 2 exists. So if in case maybe you find 2 different answers on the first one and the second one here, it means that the limit does not exist. But if you find the same answers, it means that the limit exists. Okay. So in this case, we have found 6 on both sides, on the left and on the right. We found 6, which implies that the limit exists. So we have proved that f of 2 exists because it has given us it has given us 6, which is not undefined. And then we've also proven that the limit of f of x as x is approaching 2 exists because the left side and the right side is giving us the same answer here. So this implies that the limit of f of x as x is approaching 2 exists. So after doing this, now you have to check, or before you check the 2 solutions, you have to find the answer for this. So the answer for this is just the answer that you find on both the left and the right. So what you do is you can now say, okay, let me just write it on top. So you can now say the limit of f of x as x approaches 2 is equal to 6. So we now move on to the last step, where we have to check whether this second step is giving us the same answer as the first step. Let me just go back here. So this is what I'm trying to talk about. So we have proved that the first one here, which is f of x or f of a, exists. And then we've also proven that the limit of f of x when x is approaching a exists. And then we are now on the last step here, where we have to check whether the limit of f of x as x is approaching a is equal to f of a. So let us check. So the first answer that we got, which is f of a, in this case, which was f of 2. So the first answer that we got, which was f of 2, so f of 2 is equal to 6. And then the other one that we got for the limit of f of x when x is approaching 2, we got 6 as well. So when you look at this, okay, let me just write it here. The limit as x is approaching 2, the limit of f of x as x is approaching 2 is giving us also 6, which is just this number here. So now, since the limit of f of x as x is approaching 2 is equal to f of 2, we can now say the function f of x is continuous. The function f of x is continuous at x is equal to 2. So this is how you test for continuity. Yeah, this is how you test for continuity. Okay, so do you have any questions on this one before we proceed? Do we have any questions? Okay, this is a straightforward thing. It's not.
Okay.
Hello? Yes, sir.
Maybe for a clarity sake,
okay.
You said earlier on, you said when you find something that is undefined, which is 0, it means it doesn't exist. And again, when you find two different numbers, let's say in the first place you have found 6, the second place you find it to be 4, it means again it doesn't exist.
No,
is that what you said?
It's not continuous. Okay, let me explain it from this.
Oh, that means it.
Yes, we are testing for continuity. So the first step here, so in case you are solving and then you find that the first one does not exist, I mean, f of a does not exist. From there, you can just conclude to say the limit of, rather, the function f of x is not continuous at a, at the given point a. So if you just, as you are solving, if you just find that any of these rules here has been broken, or the function is not following any of these steps here, you can conclude. So if, for instance, the first step here, if you discover that f of a does not exist, you can conclude from here to say that the function f of x is not continuous at a. Or when you find that f of a exists, and then you discover that when you find the left side, the left side is not equal to the right side. So if, on the second step here, so if you discover that the left side is not equal to the right side, it means that the limit of f of x as x is approaching a does not exist. And if it does not exist, you can also conclude just from here that the function does, the function is not continuous at the given point a. That's what it means. And then from there, when you just deal with the first step and the second step, you just have to compare the answers that you found on the first step and the second step. If the answers are equal, it means that the function is continuous at that given point a. But if the answers are not equal, it means that the function is not continuous at that point. That's what it means. So the most important steps are just the first step, you check whether the what is the function, or rather you check whether f of a exists by replacing a in the given function. And then the second step, you just have to, test whether the limit, or you just have to figure out whether the limit of f of x as x is approaching a exists. And you do that by checking the left and the right side. If the left and the right side are equal, it means that the limit exists. But if the left and the right side are not equal, it means that the limit does not exist. And if the limit does not exist, it means that the function is not continuous at that given point A. And then the last step, you just check whether the limit of f of x is equal to f of a, which is just the same as just comparing the answer that you have here and the answer that you have on this point. Hope everything is clear. Move on to the next one. Okay, let's try to look at the first principle. So the first principle is a straightforward principle, of course. It's not something that we're going to take a lot of time to discuss. Okay, so I'm sure if you watched the video that I sent, I think on Monday in the group, you agree with me that the first principle is just a way of differentiating functions. If you have, let's say, for instance, f of x as a function, if f of x is your function, according to the first principle, dy dx, or let me say f prime of x, or f of x prime, this one is found by finding f of x plus h, then minus f of x, and then everything divided by h. Of course, here this is supposed to be the limit of something. Let me just write it properly. So if f of x is the function that we've been given, f prime of x, which is the derivative of f of x, is just found by finding the limit as h approaches 0 of f of x plus h minus f of x, everything divided by h. So let us try to differentiate this, or to find the derivative of this using the first principle. So sometimes it's called the definition. So what we just need to do is to find f of x plus h, meaning while there's x in this main function that we've been given, we just put x plus h. That's all. So it's very simple. So let's find the limit as h approaches 0. So f of x plus h. So in this function, I'm going to replace x plus h. So, okay, for the sake of learning, let me reduce this power to 2. Let's find for f of x is equal to 4x to the power 2. Okay, so this is what we're going to do. So while there is x there, I'm going to put x plus h. So I'm going to say 4, and then x plus h, then to the power 2, and then minus f of x is just the same function here. So I'm going to put back 4x squared, then everything divided by h. So what I'm going to do here is I'm going to simplify this part, just this part here. So we have the limit as h approaches 0 of this function. So when I simplify this, it will give me a quadratic equation, which is x squared plus 2xh plus h squared. And then minus, we have 4x squared there. Then we say everything divided by h. So we are going to multiply this 4 with everything in the brackets there. So we have the limit as h approaches 0 of 4 times x squared there, we're getting 4x squared, 4 times 2xh, we're getting 8xh, then 4 times h squared, we're getting 4h squared. then everything divided by h, then we say we have a minus 4x squared. So when you check this 4x squared and this other 4x squared here, they are subtracting and they're giving us a 0. So we're just remaining with 8xh plus 4h squared. So we can simplify this. We're going to have the limit as h approaches 0 of, I'm sure since h is common there, we can factorize it, we can factor it out. So we have h outside, then while there's 8xh here, we just remain with 8x. Then while there's 4x squared, we just remain with 4h, and everything divided by h. So we have h there, and that h will cancel. So just remain with the limit of 8x plus 4h as h approaches 0. So what this means, remember the rules of limits, you just have to replace 0 where there's h. So when you replace 0 where there's h there, you're going to have 8x and then plus 4 times 0. And then the final answer will therefore just be equal to 8x. So this is how you use the first principle. So if you have not watched the video that I'm talking about, make sure that you watch it immediately after this, in case you are failing or you're finding it difficult to understand this. Yeah, at least there I explained a bit. And in case you need some more practical questions where I've explained how to use the first principle, you can contact me, or you can inbox me after the lesson. I'll send you the link so that at least you can have more experience on how to use this. So the first principle is just this expression here. This is the definition. It's the one that you use to differentiate. Okay, let's also look at how we can differentiate the second one here. Okay, so this is how we're going to do it. So the first principle is very simple. So let's look at how we can solve this one. So the question is y is equal to 2 over the square root of x. So how can we differentiate this using the first principle? So y prime is going to be given by the limit of f of x plus h, and then minus f of x. So in this case, we're dealing with y. So our f of x is equal to y. So if you want, you can just say let f of x be equal to this expression. But even just writing like this is not a problem. So we have this as h is approaching what? As h is approaching 0, then everything divided by h. So we can put x plus h while there's x, which is this part. So to find y prime, we're going to have the limit as h approaches 0 of 2 over, while there is x there, I'm going to put x plus h. Then we subtract everything by the function, the original function, which is 2 over x, 2 over the root of x. Then we're dividing everything by h. So this one is also straightforward. So what we do, we can, so what we can do here, we can first find the common denominator on top here to simplify the expression. So how do we do that? So to simplify the expression, we can first find the common denominator. So we'll have something like this. So on top here, if we find the common denominator, we're going to have the root of x multiplying root x plus h. Then when we say this into that, we're getting the root of x times 2, we're getting 2 root x. And then we also have minus this part into this part, we're getting this. So we're going to have the root of, 2 root x plus h. And then everything will still be divided by h. So dividing everything by this h here, it's just the same as putting h in front. So from there, we say y prime is equal to the limit as h approaches 0. And by the way, you should never replace this h just at the beginning. First, you have to simplify this expression to a point where this h cancels with at least an h on top there. That's when you can plug in the value of h, which is 0. So don't replace 0 just from the first or the second step. You first have to simplify the expression. So you see this h has to cancel with some h on top there on the numerator. So how do we simplify that? So when you look at this expression here, when you look at this expression on top, rather, it's a difference of 2 squares. This okay, let's introduce the conjugate. That's when we talk about the difference of 2 squares. Okay, so we have 2, and then we have the root of x. I'm factorizing 2 out. Root x minus root x plus h there. Then we are dividing everything by h. Then we have the root of x times the root of x plus h. So the conjugate of the numerator there, since we have a minus in between here, we're going to put a plus in the conjugate. So we have the root of x plus the root of x plus h. So we're multiplying the numerator and the denominator with the same conjugate. So we have the root of x plus the root of x plus h. So when you multiply the numerator there, it's just the same as having the limit as h approaches 0 of, we have 2, and then the first one, this root x times root x, can also be written as the root of x squared. Or let me say, since this is a difference of 2 squares, we can also write it as the root of x squared minus the root of x plus h, then squared. Then we're dividing everything by h, open brackets, root x, then root x plus h. Then we're also multiplying it with the conjugate, which is root x plus root x plus h. So on top there, if we simplify the expression, we're going to have the limit as h approaches 0 of root x squared will give us x, and then we say minus, then we have root x plus h squared will give us x plus h. So when we simplify this expression further, we're going to have h root x, then root x plus h, then in brackets we still have root x plus root x plus h. Then when you simplify this further, we're going to have the limit as h approaches 0 of the numerator there. You can see that this x minus this x, the answer will be a 0. So just remain with negative times h there, which is negative h. So we'll have 2 and then negative h in brackets, then everything divided by the whole denominator there, which is root x. And then root x plus h. Then we have root x plus root x plus h. So you can see that this h and that h can cancel, and the remaining function will be the limit as h approaches 0 of, on top there will just remain with negative 2, and then down we're going to have the root of x because this h has cancelled with the h on the numerator there. Then we also remain with the root of x plus h. Then we also have the root of x plus the root of x plus h. So at this point, since the h in the denominator has cancelled with the h on the numerator, we can now, we can now replace the value of h in the expression. So when you put h, when you put 0 where there's h, we also put 0 there. We're just going to remain with y prime, which is equal to, on top we remain with -2. And then down here, we're going to remain with, the root of x multiplying. Here, if we put a 0 there, we'll just remain with the root of x. Then if we put a 0 where there's h here, we'll have the root of x plus, this side will also just remain as the root of x. So what this means is that if you simplify this further, you get -2 on top, and then the denominator will simply just be root x times root x. This will give us x, then open brackets, and then you are going to get root x plus root x there will give us 2 root x. So simplifying this further, this 2 and that 2 will cancel, and it will just remain with -1 on top, and then the denominator will simply just be x root x. So this is the solution after differentiating this expression using the first principle. So in case you want to prove this, if you know how to use the power rule or the change rule, or even the quotient rule can work on this question. So you can use any of the 3 rules which I've told you. You can just use any of the 3 rules and try to prove that the same answer that I've gotten here, which is -1 over x root x, is the same answer that you're going to use whether you use the quotient rule, the chain rule, or the power rule. Yeah, so whichever rule you are capable of using to still give you the same answer. So do we have any questions about the first principle? Because the first principle, according to my understanding, the first principle is just this expression here. That's all. Just master this expression. The remaining part, the remaining simplifying part is just, these are just functions. You just need to simplify. Yeah. Remember the rules of surds on the conjugate, all those things apply. So the rest of the whole expression here is just simplifying. The first principle is just this expression. So after this lesson, I'm going to give you an exercise, which I'll expect you to submit tomorrow. Just want to see if you have gotten the point on the continuity test. Okay, so I was saying, after this lesson, I'm going to give you an exercise just to test whether you've understood the first principle and the test for